Guys, this is our first online video, and well, this is a movie, and one thing you can do with movies is you can stop them at any time you want and go back to look what you didn't understand, or when I'm doing a problem, just pause the movie and try to solve it for yourself first, if you know what to do or you think you know what to do. So this is an excellent way for you to test whether you understand everything, and then you look at the solution. Okay, so this topic that we have to do now is determinants. We are in a new chapter, and what is a determinant? We're going to have matrix, and to a matrix we're going to associate a determinant. And we have actually done this already for 2x2 matrices. I want to review the calculating the inverse of a 2x2 matrix. I write an arbitrary 2x2 matrix here, and then the inverse, we had to calculate a number here. Namely, we take the product of the diagonal elements and subtract the product of the off-diagonal elements, and then we also needed to switch these two numbers. Now they are the same, so you don't see that, and put negative signs for these two numbers, so -2, -4. Now I took a very easy case because this number is now just 1, so we get this matrix. The inverse of this matrix is just this. All right? Remember that, right? But what is now important to us actually is this number, and that's what we're going to call the determinant of A. So let me do this in general. If A is a matrix and we have A, B, C, D are its entries, then we define the determinant of A, that number that we need here to in the denominator of the inverse, and that is defined as the product of the diagonal elements A, D, minus the product of the off-diagonal elements, BC. Okay, we have seen this, done this, and that is easy. But our goal is now to calculate determinants for bigger matrices of bigger size. And we start with a 3x3 matrix. So let's move to the 3x3 matrices. I'm going to work on an example. So the determinant of a 3x3 matrix, that's our goal. Here is an example. A is the matrix 1, 3, 0, 4, 2, -1, 2, 1, 2. And so the question is, what do we mean with the determinant of A? All right. In order to explain this, I have to introduce some new notation, some new notions. First of all, we're going to talk about the elements of A in a more, before here we just call them A, B, C, D, but we want to be a bit more systematic, and we're going to call the elements in the matrix A, I, J. So you see there are two indices here. There's an I here, and the I is the row, and the J will mean the column. So let's check that out first. What is A22? Well, that's an element in the second row and in the second column. So that's the element 2. And likewise, we could do, for instance, A12. Now we are in the first row, but we're still on the second column. All right, let's work the next one out. A32. We are now in the third row, but we're still in the second column, so this is the element 1. Okay, the determinant, I'm going to write down what it is, the formula. It is A12, C12, plus A22, C22, plus A32, C32. Now the A's, we know what they are. I haven't told you what the C's are, okay? So but before I define the C's, I actually have to define the M. Let me do this here. Let's start with the first one, M12. And once I have M12, I will get C12 from that. So what is M12? How do you get M12 from a matrix? It's called by the M stands for minor, but that's not so important. 1, 2. Okay, so 1, remember, means the first row, 2 means the second column. Let's look at what element we're talking about. So we are talking about the element first row, second column. So we are talking about This is the element, remember, this is 3, right? We have already figured this out, that this 3 is. But what we do now is we take, the element is in the first row, we scratch out the first row, and it is in the second column, so we scratch out the second column. And you see there are 4 numbers remain, and these will be the numbers that I'm now going to use a determinant from. So the determinant of which matrix? 4 minus 1, 2, 2. That is what M12 is going to be. Okay, I'll do it one more time. I'll clean it up a little bit so that you can see better what we're doing. I'm going to start the same problem over again, but so that we have a clean board here. So let me erase all this, but we keep the formula. Okay, so let's do it again. Our matrix was 1, 3, 0, 4, 2, minus 1, 2, 1, 2. And then we wanted the determinant of the matrix. But I'm going to also already introduce a notation. Instead of writing determinant of A, that's what we wrote before, that's sometimes we use this, but if we really have a matrix, we just do this. So notice the difference, I don't have the hooks anymore, right? So determinant is just straight lines. Okay, so according to the formula, I'm using the same formula again. It's A12, C12, plus A22, C22, plus A32, C32. I'll explain why I chose these particular ones later. But for now, let's calculate what this is. Okay, we go again. A12, that was first row, second column, so we're talking about the element 3. And then we scratch out that row and the column, the first row, the second column, and we are left with 4 numbers, and that will be our M12. Okay, so M12 is the determinant that you get by, I'll show again, you delete the first row, you delete the second column, and you have 4 minus 1, 2, 2. Okay, so that's how we do it. Now this is just a determinant. What I've left with is now a 2 by 2 determinant, and I know what to do. Multiply the diagonal element, that's 8. Subtract, don't forget the subtraction here. Product of these two, so minus 2. Minus 2, that is 10. That's M12. Okay, but it is C12. So what is that then? Well, C12 is the same as M12, but there comes a sign here, and the sign is calculated in 2 different ways. You can either calculate it as the sum of the row and the column. So here we are in the first row and in the second column, so the whole thing is 3. 1 plus 2 is 3. And of course, if it's an odd power of minus 1, then get minus. So C12 would be minus M12, which is minus 10. Okay, so this is 10, but we have the minus, so we get minus 10. Okay. I said there's another way, and it's actually easier to do and it's easier to remember, is there is a pattern. So if we have a 3 by 3 matrix, we make a kind of chessboard with pluses and minuses. Okay, so that's the pattern I want. And now, since we're talking about this element in the first or third column, you see it's a minus sign. That's why we have this minus here. Okay, let's check this out, how this works with this guy here. Well, A22, okay, what is A22? I'll do a different color. A22 now is in the second row, second column. So we're talking about this element. So A22 is equal to 2. And what is then M22? Well, M22, you scratch out the row and the column that it belongs to, and you're left with 1, 0, 2, 2. All right? So 1, 0, 2, 2. Again, if you don't see where does this number come from, 2, 2. So second row, second column, and what is left is the elements 1, 0, 2, and 2. These are exactly the elements that I wrote there in my determinant. Okay, So this is a 2 by 2 matrix. It's very simple. Product of these two, 2. Product of these two is 0, so the whole thing is just 2. And what is C22? See whether you can figure this out already. But look at the pattern now. Second row, second column. So we're talking about a plus sign. So it's also 2. All right. There's one more. Let's do that in a different color. A32. Now we are in the third row, but still in the second column. Notice that's the only thing that we are, in all 3 cases here, we were always dealing with this column. And so now we are using this element, 1. So question, what is C32? Let me do this here. C32 is, well, okay, it's the third row, the second column that we scratch out, and what is left is 1, 0, 4, minus 1. 1, 0, 4, minus 1, correct? Okay. So it's a determinant. We can add 2 by 2. That is the product of these two, that's minus 1. The product of these, that's 0. So we only have a minus 1 left. But, no, sorry. This, okay, sorry. I misspoke. This is not C32, right? Because C32 has a sign. And so this was actually M32, I calculated. So this was M32. I apologize. Because C32 is this number, but with, I don't know yet what the sign is. Let's look. Third row, second column, we're talking about a negative sign. So it's negative form. Okay, so let's put everything together now. We have, I'll write it here. So the determinant of A is equal to A11, that is 3, times C11, that we calculated here, minus 10, plus A22, which is 2, times C22, which we calculated here, 2, plus, and finally, this A32, that was 1, times C32, which we calculated here, that was minus 1, which is also 1. Okay, what we get is minus 30 plus 4 plus 1, that is minus 25. That is the determinant of this matrix. But you will say, why did you choose, why do we have to do this particular formula? We were working with this second column, okay, I see that, but why? Why that one? Well, the answer is it doesn't matter. You can choose what column you use and even what row you use. So let me now show you that it doesn't matter how you do this. I'm going to do the same matrix, but in a different choice. And then you also can figure out how that will work. All right, so here is my matrix again. Start with black again. So my matrix, what my determinant that I was doing, sorry, is 1, 3, 0, 4, 2, minus 1, 2, 1, 2. And so now I'm going to calculate this using row 1. So what is the calculation I did here? Let's go back. I used column 2, right? You notice that all the 3 elements that I was looking at were from column 2. So this we would call row 2. Sorry, column 2, sorry about that. Column 2. But now I'm choosing something totally different. You see, it really doesn't matter what I choose. I choose row 1. Now let's first write down what that would mean in the formula, right? That means I have to go through this row. So I will look at these 3 elements. I'm going to write down the formula, but actually really the formula is not really important, it's the technique. So I'll write down the formula, but then I'll work just out. But the formula would be, okay, we have to have this element is the first element, the first row, first column, and the corresponding C. By the way, the name for C, let me perhaps call these names here. So that this is a minor, but that's not, we're going to use that much. This is what matters. This is called a cofactor. That's why you use C of cofactor. Okay, so this is the first element, first row. We stay in the same row, so this will be again an element in the first row, but now in the second column. The corresponding cofactor plus third row, that's the last element, third column, first row, third column, that is the last element, that is this. Okay, that's the formula. But as I said, actually the formula is not so important. What we'll do is we'll just work it out here visually, which I'll do now. Okay, so we do what we call expansion along row 1. We start with the first element. That is a 1. So we have to now calculate what is C11. C11, and let's now immediately take care of the sign. I'll do the pattern here of signs again. Plus, it always starts with a plus. Minus, plus, minus, plus, minus, plus, minus, plus. This has to be a 3 by 3 matrix, right? Later we'll see by 4 by 4 matrices you have to make a pattern with 4 by 4s. All right, so we start with the top element, which is a plus. So this plus, I'll write it here for emphasis. So this plus. And then we have a determinant. What is the determinant? Well, now we know how it works, right? You scratch out the element, the row and the column it belongs to. And what is left is 2 minus 1, 1, 2. Okay? So 2 minus 1, 1, 2. I do it again visually in case you missed it. Oh, that's... sorry. So we sketch out this row and the column, and what we left is this determinant. Right? Okay, that's easy to calculate. That is 4 minus 1. Right? This is 4. This is the product of the end of the off diagonal. So there is 4 minus 1. That is 5. Okay. Let's do. So A11, I'll write it here. A11 is 1. C11 is 5. Let's do the next one. A12. In other words, if you just visually do it in a different color, it's the next element in my same row. That is 3. And C12, remember this is the name, the numbering that we use. C12, it now corresponds to this sign. So it comes with a negative sign. Then we have again a matrix that we obtain by deleting the row and the column. So 4 minus 1, 2, 2. Okay? 4 minus 1, 2, 2. Again, I delete this, and what I'm get is this matrix that I wrote down there. Okay, that is, don't forget the minus sign, and then we have this product, 8 minus this product, minus 2. So that is 8 minus 2, that is 10, so the whole thing is minus 10. Okay, and then finally A13, right? That is the last one that we have to do, A13. What we're talking about, I'll do it in a different color. We're now talking about the first row still, but the third column, and that is 0. Well, if that is 0, then I should really not worry anymore, right? If this is 0, it doesn't really matter what C13 is. But let's just calculate it. C13 is, okay, first of all, what's the sign? Well, this is now again a plus sign. So we have a plus sign, and then we delete the row, we delete the column that it belongs to, and we have 4, 2, 2, 1 left. We calculate this very quickly. That is 4 minus 4. Oh, look, this is also 0, but that's just coincidence. Don't make anything out of that. Okay, so put it all together. The determinant of my matrix A is A11, that's 1, times C11, C11 was 5, plus A12, that was 3, times C12, this is this guy here, that's minus 10, and then plus 0, right? Because this was just 0, whatever it is, it's always 0. That is 5 plus minus, well, plus, sorry, I should say minus, right? This is 5 minus 30 is minus 25. Look, the same number that I found here. And that is now the beauty of this thing, is it doesn't matter how you do it. Okay? So I want you to try now the same matrix, so we already know what the outcome is, but just let's try it together, what we get. All right. So I'll write the matrix one more time. It is 1, 3, 0, 4, 2, minus 1, 2, 1, 2. And let's expand this now using column 1. Stop the movie, try to do it yourself, and once you've done it, double check now how I explain it. I'm going to do this now very quickly. Column 1, we are talking about this column. So we walk through this column, all right? And we do this as follows. This is our first element. So 1, I'll keep track here also of my signs. So this is a plus sign, so plus 1 times the cofactor. And the cofactor we get by scratching out the row and the column it belongs to. So we have 2 minus 1, 1, 2. You got that? All right, so let me get rid of these lines. That takes care of this element. I do the other element in blue. This element now is the next one, but remember this comes with a negative sign, so negative 3. So this negative here comes from there. And what is the 2 by 2 matrix that we get? Well, scratch out, and you see 4 minus 1, 2, 2. Okay, I'm gonna 4 minus 1, 2, 2. Okay, we'll work this out later, but that's what the rest of the formula. Oh, I said column 1, I'm doing row 1. Guys, you didn't see this. So let's erase this, right? This is not what we want. We're not doing this. We are doing, because I recognized this, that I've done this already. It's column 1, so I went to the wrong element. I have to go to the next element in the column, this element. All right. But what is the sign? Okay, that's the sign, negative sign. And this is what happens. It starts out, you can figure out, right? If you walk in a column or you walk in a row, the signs change. But be careful, depends in which row or which column you are, it starts with a positive or a negative. Okay, so we have a minus 4, that's the element, that's the A, the formula, right? In the elements we have the formula, the elements, and now the matrix, the 2 by 2 matrix. Scratch out this, scratch out that, what's left? 3, 0, 1, 2. 3, 0, 1, 2. And then lastly, we walk into the column. Okay, we got it now. This 2 plus 2. Why plus? Well, because we are now at the plus sign again. So this is this plus sign. And then the matrix we get is we scratch out and we're left with 3, 0, 2, minus 1. And this should be 25, minus 25. Well, let's check. 1 times 4 minus 1. That's a diagonal element. Minus 4 times 3 times 2, that's 6. 0 times 1 is 0, so it doesn't do anything. Plus 2 times minus 3. So that is 4 minus 1, that is 5. Minus 24 minus 6. So that is minus 30 minus 25 again. Okay. So just very quickly before we move to the higher, bigger sizes, let's do one more example. This times a different matrix. So tell me what is, let's say, C23 in the following matrix. 5, 1, 1. 0, 1, 2, 3, 1, negative 2. Okay, C23. Just stop it and try it yourself, but I'll explain it now. C23, we're talking about the 2 means the second row, the 3 means the third column. So we're talking about this position. And to calculate C23, there's 2 things we have to do. We have to look at the pattern of the signs. So the position corresponds to a negative sign, so C23 is negative, that's this negative here. And the 2 by 2 matrix you have is you scratch out this, you scratch out this, and you're left with these 4 elements, 5, 1, 3, 1. And so that is minus. 5 times 1 is 5, 3 times 1 is 3, subtract. So that is, this is 2 minus, so minus 2. Now I just only calculate one cofactor. If I would have to calculate the determinant, I would have to walk through either a row or a column. Okay? Now, I'm going to leave this for exercises to do, try yourself with 3 by 3 matrix. And so the next movie will be about what to do in a 4 by 4 matrix. Okay? You don't have to write a comment on this movie. Write only comment that you at the end of the next movie that you have seen both movies. Don't forget that. This is important, right? Because otherwise, I do not know whether you actually have been working. So, to repeat, when you want to make a comment, first of all, you have to log in. I explained how to do this on the website. You should also subscribe if you have not done that. If you still have that big red button asking you to subscribe, push on that, okay? You can also put the notify bell, but you don't have to. And then leave a comment on the second movie, not on this one, it's not necessary. But if you have questions about this, you can leave comments on this movie, all right? See you in 1 second.